Hello, welcome students. Welcome everyone to our today's session that is related to class 9 chapter is circles, and we have to discuss today our exercise, that is exercise 10.4. In the previous video we have discussed about the theorem that we will utilize here in our exercise. Those who have not seen the video, just go through the link, see the video so that it is easier for you to solve this exercise. Okay, now see the first question of our exercise. Two circles are there and the radii is 5 and 3. They intersect at 2 points and the distance is 4 from their center. Okay, distance of their center means the distance of O and O dash. It is given here 4. What you have to find out? We have to find out the length of common chord, that PQ we have to find out. Okay, what we are having? We are having centers, their radius, then we are having the common chord and we have to find out their center. Now see here this diagram. Now I think this diagram is clear to you all. We have drawn two circles, one of 5, one of 3. This O dash, it is the center. This line, it is 4, 5 and 3. What we have done, just see, from this L to O dash we have assumed it as x. If the whole is 4 and this portion is x, the remaining is 4 minus x. Okay, now we are having angle OLP or angle OL, you can say this one O dash LP. Okay, so this one is 90 degree. Why this one is 90 degree? Why we can say this one is 90 degree? We have read down in the theorem also. Okay, so that is the reason it is 90, as well as this, because it intersect means bisect perpendicularly, na? So PL is also equals to LQ. Now what we are having? We are having a right angle triangle. Which is the right angle triangle? OLP. This OLP, it is the right angle triangle. This is 90 degree. Now in this triangle we can find out PL here. Okay, in this triangle OL is known to us, 5 is known to us, we can find out PL. Okay, just see this one. This PL, it is equals to this OP square minus OL square. By the Pythagoras theorem we can find it out. So we are getting this equation. Okay, equation we can easily solve, as we have solved the algebraic expressions, we can solve this equation. Now we will take the next triangle. Which one? O dash PL. In this triangle again we can find out the value. So now see, from here we are finding the PL square, from this triangle also we are finding the PL square. So we have equalizing both of them, and while we have equalizing both of them, just have a look here, we have equalized both of them, then we can find the value of x. Okay, but we can find out value of x. Now when we are finding the value of x, what we are getting? That x is 0, means from L there is no distance of O dash, means L and O dash coincide, means L and O dash coincide, means this PQ, this PQ, it is a diameter of smaller circle. Why? Because this O, it coincide L, and if it coincide L, then this one is the whole, it is the diameter, because this L to P, it is the radii, so this one is the diameter. So what will be the value of PL? It is 3. It is 3 only. And if PL is 3, then LQ is also 3, and then whole is 3 plus 3, that is 6. So the length of the required common chord is 6. Okay, similarly one more question, question number 2 is here. If two equal chords of a circle intersect within a center, okay, these two equal chords are there, they intersect within a circle, we have to prove that the segment of one chord are equal to the corresponding segment of another chord. This we have discussed in the example also, little bit similar to it, but here what we have to prove, the corresponding parts are equal. Just see what are the corresponding parts. This AE, it is correspondent to DE, so we have to prove that A is equals to DE, and we have to also prove that C is equals to BE. So this we need to prove the corresponding parts as equal. And what is given to you, what is given to us, that AB is equals to CD. AB equals to CD, it is given to us. Now when we have done the construction, what the construction we have done, we have drawn this OM that is perpendicular to AB, as well as this ON that is perpendicular to CD. Okay, and we have joined this O to E. Now what we are having these two triangles. Now have a look here carefully. We are having AB is equals to CD. Okay, and one more thing we are having, that from O to M it is a perpendicular. So perpendicular from the center, it bisect the chord. So AM is equals to MB. Okay, or so how we have done, just see here. First of all, what is given to us, that both chords are equal. If both chords are equal, then they are equidistant from the center. Equidistant from the center means these two are equal. Okay, now one more thing given to us, it is 90 degree. This one we have proved, this is common. So we are having three things in this two triangle. We are having three things. Now by the RHS criteria, it is congruent. Okay, and what I have told you, that by CPCT ME is equals to NE, this portion we are having as equals. Okay, now what I have told you earlier, that this is bisecting the chord. So it is equals to MB, and DN it is equals to NE. Okay, but we are having this ME is equals to NE. So what we do, we just subtract it or add it to AM or DN. In AM or DN, we are adding ME and NE because both are equal. And once we are adding it, then AE is equals to DE. Okay, AE is equals to DE. Now what we do, from the whole AB is equals to CD, we will subtract AE and DE. Now once we have subtract AE and DE, what we are getting? We are getting CE and BE. So this is our result. Okay, so what you will do after it, after proving both triangle congruent, you will prove that AM is equals to BM, means half is equals. Okay, now AB is equals to CD. Then what you can do, you can just subtract the given means AM is equals to DN, then you will add the equals, that is ME and NE. So this is our question number second. Okay, just see our third question. In our third question is, if the equal chord of a circle intersect within a circle, prove that the line joining the point of intersection to the center make equal angle with the chord. Here what is given to us, these chords are equal, AB and CD. Now what we need to prove, that OEA, this OEA is equals to OED. These two are the equal. Now same construction we will do, we will draw the perpendicular. Now in these two triangle, what we are having, just OM is equals to ON, because for equal chord perpendicular are equal. Then OE, it is common, angle is 90. So by RHS both triangle are congruent. And once both triangle are congruent, the remaining parts are equal. And what are the remaining part? OEM and OEN. Now we can expand it to the A and D. So OEA is equals to OED. Okay, so this is all regarding our question number 1, 2 and 3. Remaining of the question we will discuss in the next video. Okay, just see the previous one also for the theorem, so that the things are clarified for you all, you can easily understand. Okay, without theorem you can't understand what is going on in the questions. Okay, so just see the slide, complete your work, and for any query you can just comment or message me. Thank you, take care.